Uh, Page 23, I think we're able to work through most of the problems. Let's look at, okay, so today we're going to look at some problems where we're going to see a combination of different vectors, creating that resultant vector and just being able to manage information from both vectors. I think the hard part is the setup. Once you get past the setup, then once you get to the resultant vector, then you can use inverse tangent and Pythagorean theorem to find your direction and magnitude. So once you get that point, I know you guys can do that. So, but let's look at example 5. I think we got through 1 through 4. So example 5 on page 23. Okay, so example 5 says airplane is flying with an airspeed of 500 miles per hour, heading due north. If a 50-mile-per-hour wind is blowing at a bearing of 280 degrees, determine the velocity and direction of the wind relative to the ground. Okay, so we're going to be playing with this equation a bit. Some the more difficult ones are ones where it's not arranged in a way that we would expect. But here's the idea: is that we can say vector A, which represents the airplane, which is where the airplane is pointing to and where it's kind of aiming towards, plus vector W, which is the wind. If I add those two vectors together, we end up with our resultant vector, which is really the true movement of the plane, right? Even though the plane is pointing in one direction, if it gets pushed off course by the wind, then the resultant vector is telling us, you know, how the plane is actually moving and the speed. Okay, so that's the idea here. Okay, so let's create component form for the airplane. So airplane is flying with an airspeed of 500 miles per hour on a heading due north. So what vector can we create for the airplane in component form? Yeah, so 0 because this plane is not moving east or west, it's going north, and we associate north with positive 500 miles per hour. Or at least it's attempting to, right? It's aimed towards the north. But we have a 50-mile-per-hour wind that's blowing at a bearing of 280 degrees. We have to make an adjustment, right? This is not the true degree measure. How do we deal with bearing? From yesterday, we had that bit of a shortcut, right? Yeah, subtract 450. We know bearing means that we're counting from 90 degrees, so everything gets shifted. So we think in terms of, instead of subtracting 360, if we subtract from 450, we can get what that bearing is really in terms of a standard position. So this is the true standard position of the wind, and we have magnitude and direction of the wind. We can create the component form for the wind. Magnitude cosine 170, magnitude sine 170. Okay, use our calculator to clean this up. Enter in your calculator, 50 cosine 170 and 50, sine 170. Now we know that if we add the two vectors together, we can get the true direction of this plane, because that wind is going to push it off course a little bit. Okay, the resultant vector means that we're just going to be adding these two vectors together. Horizontal with horizontal, vertical with vertical. Okay, once you get to the resultant vector, then it's easy because you can find the velocity and direction using our Pythagorean theorem, our magnitude formula, and our theta formula. Okay. Now, once we get to theta, we may have to make an adjustment, right? Which quadrant is this? Yeah, second quadrant, so we got to involve 180, right? So try that, see if you can finish that problem here. Find the velocity or magnitude, and then find the direction. Okay, let's look at what we found. Okay, magnitude, Pythagorean theorem, we should have gotten 511 miles per hour. That's how fast the plane ends up going, because the fact that the wind is kind of pushing it, it's kind of increasing its velocity. But the direction is also changing too, right? It's aimed at north, but it's actually, because of the wind, it's going to get pushed a little bit out to the west, 95 degrees. Okay, page 24. A lot of these problems will feel pretty familiar, like on page 23. So go ahead and try number 1, and I'll work through the problems as you guys are working through them. Okay. Anybody still need this page? Okay, taking a look at number 1. Any questions here? All right, we're just taking our 2 vectors and putting it into vector between angles formula. Okay. Biker is walking a trail 2.5 miles per hour at a bearing of north 50 degrees west. So we have to kind of draw this out, right? Try to figure out what direction it's headed towards and how to get it into standard position. Okay, any questions about converting this to standard form? Yes.
Never mind.
Okay. Okay, airplane traveling 300 kilometers per hour due east. The wind is blowing 35 kilometers per hour at an angle of 255 degrees. What's the resulting speed? What's the direction? So before we get to resulting speed and direction, let's get that resultant vector, right? So just like number 5 from page 23, we want to understand that there's a formula here, right? The airplane is trying to travel in the direction, but the wind is pushing it in a different direction. And so the plane is actually going to end up moving and pointing in a different direction because of the fact that the wind is pushing what the airplane is initially trying to do. We think of east as positive, right? East is moving to the right. Getting to the resultant vector is the challenging is the part that we have to make sure we can do, but everything else should feel easier now, right? Pythagorean theorem will help you get to the speed, and then inverse tangent will help you get to the direction. Okay, kilometers per hour. Okay, which quadrant is this in? Fourth quadrant, yeah. When you make that adjustment, right? Thank you. Any questions with 3? Okay, number 4, helicopter is moving at a bearing of 105 degrees with a velocity of 52 kilometers per hour. If a 30 kilometer per hour wind is blowing at south 25 degrees east, find the helicopter's resulting velocity and direction. So same idea here. We have helicopter pointing at a certain direction. The wind is gonna change its course. We want to figure out what is that resultant end result of that helicopter's movement. Okay, we do have to make an adjustment, right? Helicopter doesn't tell us standard position, so we have to get to that theta here. So if it's just bearing, that means we know it's just from that north direction, right? We got to subtract from 450. Okay, let's build our vector for the wind. The wind is blowing south 25 degrees east. So we know it's going to be pointing south. It's getting pushed east, so it's going to end up in the fourth quadrant. Fourth quadrant, right? Any questions before? Okay, number 5. Meredith is skateboarding along a path at a bearing of 70 degrees for 35 meters. She then changes paths and travels for 45 meters along path at a bearing of 60 degrees. Find the resulting distance and the direction bearing of her path. So that's a little bit different, is that when we get to theta at the very, very end, we have to convert it to bearing. So we have to, subtract from, or we have to understand that bearing is counting from that 90 degrees. Okay, but we'll deal with that when we get to the end. So ultimately, I know that I have to find my resultant vector. So I'm going to call path 1 vector, path 2 the second vector. I know that that's going to end up giving my resultant vector if I combine those two vectors together. Okay, bearing of 70 degrees for 35 meters. Now, sometimes when you do subtracting from 450, you will get the correct measure, but sometimes it may be a coterminal angle. So what happens when we do 450 minus 70? Yeah, 380, but we can quickly adjust that, right? Because we know that we can always get something between 0 and 360 if we add or subtract 360. So if I subtract 360, I know 380 is the same thing as 20, right? So it's just either you can measure directly. If it's a small enough number, you can probably just measure from that 0 degree and realize, oh, 90 minus 20 is 70. Or you can always use that 450 formula. Just understand that if something doesn't quite fit in that 0, 360 range, you just keep subtracting 360 until you get to that range, right? Changes path, travels 45 meters at a bearing of 60 degrees. You can do anything with bearing. If it's a small enough number, you can just say 90 minus 60 is 30. Or you can do subtracting from 450 and then keep subtracting 360 and you'll get the same thing. So theta 2.
If we use 380, would it change anything?
It wouldn't, no.
Do you want us to make it so
Yeah, I want that theta to be something that is between 0 and 360. Yeah. Get those decimal values and then you can add them together. Now we want bearing, so bearing means that I'm starting at 90 degrees and I have to move in a clockwise direction. So really I'm doing 90 minus 25. Okay, any questions? I'd like to get a head start into day 2. Word problems, these are a bit more challenging. So just like for us to kind of get a head start. We're not going to get too far into it, but we can at least kind of begin the process and spend Monday finishing off this rest of this worksheet. Okay, page 25. Okay, so 25 here says, to reach a destination, a pilot is plotting a course that will result in the velocity of 450 miles per hour at an angle of north 60 degrees west. The wind is blowing 50 miles per hour to the north. Find the direction and speed the pilot should set to achieve the desired results. So this is a little bit different here, right? Because what's happening here is the pilot kind of has to adjust the course so that it will have a result of this velocity and this direction. So it almost needs to counteract the wind in order to get that desired path that it wants to go on. But I still want us to just understand that we still are working with the same equation. We just have different information that we're solving for. So we can still say that the plane or the pilot, right? The plane's aim plus the wind is going to create a certain resultant, right? We know that is true. But now we know what the wind is, we know what our result is, so we're having to subtract to get to that plane's direction, or at least the aim of that plane. So if I solve for if I solve for P, right, I get R minus W. So ultimately we can say this, that the aim of the plane is going to be the resultant minus the wind. Okay, does that make sense? Okay, it's not as straightforward as the previous, where the plane is aiming in a set direction and the wind is blowing it, and we're just trying to figure out where it's headed towards. Okay, here the pilot already knows what direction he wants to be pointing at, but he has to adjust his plane so that he can use the wind to help course correct it. So let's find the vector R. We'll find vector W. We'll subtract those two, and we can figure out the plane's direction. Okay. Okay, so the velocity is 450 miles per hour for resultant, and an angle of north 60 degrees west. So north 60 degree to the west. We know that theta is going to be 150, right? Okay, so here is the resultant vector. Okay, the wind is blowing 50 miles per hour to the north. That's an easy one to create. Zero. Okay, sorry, this is a little confusing here. Well, let's see. 50 miles per hour to the north should be 0, 50. Okay, sorry, yeah, it is, it's 50, it's 50. Okay, but we're going to subtract, right? Because it's the resultant vector minus the wind will give us the plane's direction. So 450 cosine 150 minus 0, and then 450 sine 150 minus 50. Highlight, make sure that we understand that we're subtracting these two together. Okay, so now we just do everything that we've been doing before, direction and speed. This is going to be quadrant 2. No, wait. Negative. Yeah, quadrant 2. Okay, Monday, we're going to try to get through page 25 and 26. I'm going to check your classwork all together on Monday. Okay, so I'll also check the combination of these pages on Monday. Okay, Tuesday, we'll do test review, Wednesday test review, Thursday test. And I hope to get back your quizzes on Monday.